Howdy! In this video, we're going to look at SOHCAHTOA and the connection between the XYR method. So here's a random right triangle. Notice the hypotenuse is across from the right angle. If we're considering this angle theta for trig, then the side opposite of that does not touch it. That's the opposite side. The side touching, the leg touching the angle that we're talking about is called the adjacent side. Now, if you put that triangle on the XY plane, we can relabel those sides a little bit more simply, which helps in the future with doing trig of all angles. Okay, so what we're going to do is, because when you do trig on the plane, the angle theta is always the one at the origin, starting at the standard position, going from the positive x-axis, and then a positive angle would be up from there. So there's the angle theta. Now, because then when you draw this point, well, when you draw any point xy, right, the side length of the, you can draw a triangle corresponding to that x coordinate, and that is always going to be the adjacent side. So x is always adjacent side, right? X is always going to be the adjacent side on any XY triangle, right triangle on the plane when doing trig. Y, the vertical distance, would always be opposite theta. So y is always going to be the opposite side. And we call it r typically because there's often like a big circle around it, but it's the hypotenuse. So r or hypotenuse, those are the same things. So we're going to relabel the trig ratios that you may know from SOHCAHTOA in terms of x, y, and r. Okay, so if theta is an angle in standard position, that's the point xy that I showed right there. It's on the terminal side of theta. Then the hypotenuse has length r. We could also, just for reference, notice that by Pythagorean theorem, that is the square root of x squared plus y squared. Okay, but now let's relabel these trig ratios in terms of x, y, and r. So sine of theta is always opposite over hypotenuse. So now we can write it as y over r. And its reciprocal, cosecant, then would be r over y. Cosine, instead of adjacent over hypotenuse by SOHCAHTOA, it would be x over r. And its reciprocal is secant, which is r over x. Tangent is typically opposite over adjacent. So now we can label that as y over all x, and cotangent we can label as x over y. Okay, and just a couple quick notes about this. For an acute angle theta, the trig functions of theta, they have the same values as the trig ratios of theta for SOHCAHTOA. That's what this is all about. It doesn't really matter how big your circle is, how big your triangle is, the ratios are the same. And just one more note, since division by zero is not defined, some trig functions are not defined for certain angles. That's something that you'll get more into as you do more trigonometry.